week 1.
They both have the same deadlines, right?
Yes. So week 1 and week 2 is deadline of week 2 is also next Sunday, right?
Yes.
Yeah. Okay. So we'll take session for week 2 in the next week. So this week we will be discussing on week 1. So today is so I have collected some questions from week 1. So the concepts which we have discussed in the last sessions, we will try to apply those concepts in today's session. Okay. Okay. So let me share my screen. So you have, if I can recall, remember. So you have session from 6 p.m. right for MAD. Is it classing uh, on every Saturday? So only few of you, Afrin and Vinay, right? What about others? Okay,
No, sir, I don't have MAD.
okay, okay, okay. Anyway, we'll see. Yeah.
It
So
is
this
classic, sir.
four to
2 to
six
4
will
is
work. 4 to 6 will work for everyone, right?
Yes, sir.
6 to 8 is classing for few of. Okay, we'll see. We'll talk to other instructors. Okay. Anyway, so let's start the our discussion. So today's session is about week 1 solve with us. Okay, so we'll see some questions and we'll try to answer those questions. So first of all, I will start what is this ML. Okay, so we discussed in last session also ML, what is the basically machine learning. Okay, so as all of us know, and we discuss what is the key concept about machine learning. So in what happens in machine learning actually? So in machine learning, so computer learns patterns from the data and it improve their performance on the task. Okay, so we are not mentioning right any specific rules, right? So usually in traditional programming, what we are doing, we are giving input and we are plus rules and we are expecting for the output, right? That's what we are doing in traditional programming. Yes or no? So when this programming fails, right, then this machine learning comes into the picture. So in learning algorithm, what it happens? So we are giving the input plus output some examples. So let's say we saw the examples of house price prediction, right? So in that case what happens, we are giving the data of input as well as price of the some houses, right? And based on that algorithm will find the rule. So basically what is the key thing, we are telling the computer what to do step by step, right? Rather than uh, giving input plus rule as we are doing in traditional programming. So what is the one of the example if you see in machine learning algorithm? So if you see this, if you order any food or something on Swiggy or Zomato, so usually that Swiggy delivery, I mean, it will on your app it will show you some time prediction, right? Approximately order will take 35 to 40 minutes. Yes or no, right? So how
yes, sir.
this happens, right? So Swiggy, actually that Swiggy or Zomato, they uses the real-time traffic data. I mean, what are the input will be, okay? Whether live weather updates, historical delivery records to predict how long your order will take. Okay, so by combining these things, so it will give you the one important thing called multiple regression. Okay, don't worry about if you don't know multiple regression. So basically what I'm trying to say, this is one of the machine learning technique. Okay, so it will include these kind of inputs, then based on that it will predict the time and how long your order will take to prepare. Okay, so it will include distance also, and then even restaurant preparation is speed, and then it finally it will give you the customer like accurate delivery estimate time actually. Okay, this is one of the example, it's one of the example of multiple regression. We have discussed the regression, what is the linear regression. So that is, so in linear regression, what was the case? We discussed y equal to something, let's say let's say if you have only one, you have something like beta naught plus beta 1x, so this is called simple linear regression. If you have more than one xi, so let's say I'm saying the beta naught plus beta 1 x1 plus beta 2 x2, so this, independent variables, if you have more than one, then this comes under the multiple linear regression. Anyway, so another example we saw, right? This detecting fraud in real time, right? In banking, in social media, recommending content, right? If you are watching YouTube lectures, so you will find some recommendation from the YouTube, right? So it based on the recommendation system. Then in healthcare, you can predict the disease outbreak from hospital past record data sets. Okay, some rough idea is okay. Okay, any one of you, can you tell me what is the data? If I want to discuss what is the data, then I will come to the next topics.
Collection of similar information about something.
In our case, it's a collection of vectors.
Collection of vectors. Okay, in ML we will deal with collection of vectors, correct? So what are the different kinds of data set you can find? Yeah, just think about this. This is just a discussion
Structured
session.
data. Structured data.
Okay, structured data and unstructured data. Okay, so any other thing? So structured data, like any example?
Like everything is properly organized. The columns are there. We don't.
Correct.
Everything.
Basically, I can say it's in tabular form.
Tabulated.
Uh,
Yes.
Development, right? So actually there are different kind of data sets. So first, I mean, we can see the housing data set, right? So
Yes.
if you see housing data set, so this housing data set that we see, so it's basically it's in tabular form. Can I say this is tabular data set?
Yes.
Why this is tabular data set? Let's say you will be having some features, right? Let's say number of rooms, area of house, distance to nearest metro, and then price. So it will be some tabular form, right? Some values are there. Yes or no? In a structured
Yes.
form, correct?
Yes, sir.
Now another way you can say, so each column of this table is you can consider as a features. Okay, this is one of the feature, and then this is one of the feature. Okay. So and each row is the one of the one observation, you can see, right? It's one observation for no house one, and then this is the observations for house two, and then house three, and so on. Now see this tabular data, you can, this can be represent in a very clean form, which is called, CSV format only. So there are few other forms of data sets, so that's called, you can find, maybe you have said something, image data set. Would you agree with me?
Audio
text,
files.
text data set or speech kind of data set. Okay, can you tell me this image, text, or speech, this kind of data set? Can you pack this data set in simple CSV format?
no.
No,
No.
right? So far, so good. Okay, so these kind of data will come under the
Unstructured.
unstructured. Yes. Okay, all right. Now, so the next question is, how do we obtain this kind of data? I mean, where does this data come from?
Internal and
From a,
external.
Email.
Hmm?
Email. E-
from a source.
email. Email.
Email what?
T2. Data.
Okay, okay, okay,
Data
okay,
means
okay, okay, okay.
blogs and tweets.
Okay, so suppose there is one case I'm taking. So that is, let's say, so there is, let's say, a company XYZ. Okay, so there is XYZ. So this company, suppose, has given you some historical data concerning its, sales over the last, let's say last 3 years or 4 years. Okay, now the company wants you to predict the average sales in the coming, let's say, quarter or coming month or something, right? So here, what kind of data you may get? This data get
Structured
Structure.
right.
data.
You may get the data in a tabular format. Yeah, structured data set. All right. Now, so in this case, you have the structured data set. Now, what you have to do? I mean, your problem is also defined. Right? You have a clear definition of the problem. What you have to do? You have to predict a real number by looking at the data. Yes or no?
Yeah.
Yes.
Correct. You have to predict a real number, right? By looking at the data. No, so can you tell me this situation will happen always or
No.
no, right? This may not. So suppose that another example I can you can take the Twitter one. So suppose Twitter is developing an algorithm to detect with tweets that contain offensive content and non-offensive content. So can you tell me, is this? I mean, first of all, this Twitter the example which I took for Twitter. So which one is easy? Case example of case one is easy or example of case two is easy?
Case 1 is easy, sir.
Case one is easy, right? Now,
Yes, sir.
so in this case, what you have to do? So you will be having million of twists, and you have to ask to develop an algorithm to solve the problem. Correct? So first of all, tell me,
Yes.
can you tell me this is the regression problem or any other?
First one is
First one is regression. Second one is
Classification.
Yeah, second
classification.
Sir, first,
Second is
first one is easy.
first one is yes, second one is will come under the
uh,
Classification, sir.
classification, right? You will be having only two
Yeah.
cases, right? Whether it's offensive or non-offensive.
Non-offensive.
Okay, now, so okay, so next thing comes. Let me tell you. So you have seen the two parts, right? Supervised and unsupervised, right? So first of all, can you tell me what is the meaning of this supervised? So basically, let's try to understand the meaning of supervision.
sir,
Yes.
level data
Yep.
level
Okay.
data are there in case of supervised learning.
Correct. And unsupervised
No level data.
we will only
unlabeled
have
data.
the input.
Correct.
Only input there.
So see, first of all, let's try to understand the meaning of supervision. If you see, so labeling a data set is an important part of our data preparation, right? Yeah, labeling is one of the important part, right? Now you can consider. So there may be situation where labeling is not, no, practically possible. Yes or no? So in those situations, okay, can you tell me in this situation whether label is possible or not? If you have, let's say this 1 lakh some tweets, and you have to label whether just forget this offensive, non-offensive. You have to label in some category. So is this possible to label each tweets in different,
No.
right?
No, sir.
So you will be having two kind of situations. So first one, you may get the labeled data set, and another one is unlabeled data set. Okay. So first of all, what is the meaning of supervision? So supervision is nothing but to you are basically to watch a person, or you can say to watch a person or activity to make whether the certain thing whether everything is done correctly or not, right? So that is the meaning of supervision. So what you can see basically, say for example, we saw one example of adding three-digit number, right? 313, let's say plus 122. Okay. Suppose you are a teacher and you are teaching your students this addition of three numbers. So who is the supervisor there?
Teacher is the supervisor, I think.
Correct. Teacher is the
Teacher.
supervisor, and he or she will tell you whether that particular student is right or wrong. Correct. Yes or no?
Yes, sir.
Yes.
Now,
Yes.
can you tell me in machine learning, then which thing you can consider as a supervisor?
Labels.
Label, yes.
Yes, sir.
So this label will work as a supervisor, right? This will tell you whether it's correct or wrong, right? Whether that thing is right or wrong. Yes or no?
Yes.
Okay. So whenever you have labeled data, you will go this, and with unlabeled data, I mean, where your data is not labeled, so there is no supervision available. Yes or no?
Yes.
Okay.
We will classify that. We will group the data in
Yeah,
case
that
of.
is different thing. Yes. So that will go. So in that case, we will be having only input. That's all. Okay. Now let's come to the our slides. So the very first question is, I think this is something we have already discussed, but yeah, tell me which option is correct, 1 or 2?
Second option.
Option 2. Second option.
Okay, second option is correct. Everyone would agree with this option.
Yes.
Yes or no?
Yes.
So why is the second? Why not the first one?
Because the
We
first
don't
one is
have
too
the
tedious.
specific
tedious.
rules for
And
The-
even in future, we will be getting some new rules, and we can't always code them.
Correct. We cannot make always rule. Basically, see, maybe some email may contain money, lottery, and some other let's say some other word. Let's say wow, you have received money or something like that. So you cannot make a fixed programming rule here, right? Yes or no? To identify whether email is spam or not, or non-spam. Understood? So what you will do, you will give you, let's say, for example, some 10,000 labeled email with whether that email is spam or not is spam, to an algorithm to learn the rule. And if you are giving any new email, so that will classify whether that email is spam or not spam. Okay, is this clear?
yes.
Okay. Okay, so the next question: should we always use linear regression for real world problem, or anything else you can change?
No, it depends.
So polynomial functions will help for stuff like total cost function. That's quadratic or cubic.
Correct. So we can't say this all. We have to always use, right? Yes or no? Suppose you have function something like this. Suppose you got something like this, and you are fitting linear regression. No, right? It won't work. Yes or no?
Yeah.
Okay. So what is the pros and cons if you are using the linear regression always?
Underfitting the model.
Okay.
Linear regression is actually simple to process.
Simple to process. Yeah. And what is another?
Outliers we'll miss. I mean, we'll get many outliers when trying to fit a linear regression model.
Correct. So the thing is, yeah, what I was trying to say. So we cannot always use this linear regression for real world problems. Okay. For some situations, it will be very good. Otherwise, whenever you have this kind of situations, right, it won't work that much. Okay. So this was very simple question. Now come to the
So for last question, can we also say that it's not a good fit for the like?
yeah, this is not a good fit. Yeah, because you can see the distances, right? Differences. Yes or no?
Yes, sir.
So it will be a good fit if you have data set something like this. Suppose something, and you are finding a linear regression like this. Okay, because you can see the squared error will be very minimal. Okay, so the next question is, suppose Arun goes for a walk on daily basis and records the number of steps he has covered on each day using pedometer. The following table shows the recorded data for a week. He wants to know how many steps he can cover on the next day. So which ML model is more suitable here?
Yeah, regression.
Lean.
Okay, so I got some
Regression.
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 If regression, then why? And if not classification, then why not?
Because here we are predicting a continuous numerical data.
Because labels are present.
Okay, labels are present. It's supervised learning, right? So my question is, hello, can you hear me?
Yes.
Yes,
So
sir.
my
Yes,
question
sir.
is, why regression or why not
Sir,
classification?
We are trying to predict a continuous numerical data.
yes.
Correct, correct,
He's
correct.
asking the value. Value is asking.
Value is asking, yeah. So this is the regression problem, correct? Because we are predicting the uh, continuous numerical value, correct? Okay, what if situation will change? Whether next day he will go or not? Suppose rather than steps, we change on day this he went for a walk and then second day he didn't. Then it will come under the classification.
Classification.
Correct, correct, correct. Okay, great. What about this question? Okay, so in this actually, I mean, in future you will learn even for this we will use, see, there are some other kind of models also, simple linear regression, polynomial regression, then time series models and also. For this situation, actually time series model will work properly because we are talking in terms of time. But anyway, so what we are trying to understand whether this is a regression or classification. Okay. So the next example is a behavior analyst decided to study the emotional state of his spouse at the end of each day. He decided to observe and record some, events or let's say features that happen on her daily basis. So this is the table of collected data set. So which ML model would you suggest him?
Classification.
Classification.
Okay. Why?
Because not numerical assigned to the emotion.
Correct. So we are basically predicting this category, right? One of the category, whether happy, neutral, or anger. Yes or no? Okay. So
Yes.
whenever you will deal with data, so are you going with this yes no, or you will change something else?
We won't
Sir,
change
it
now.
can be anything as long as the final is like either this or this option type. Then it will be classification.
Yeah.
We can do 1-0.
1-0. That's what. So basically, whenever you will deal, you can make it as a 1-0. Sorry, not 0.
So what was the question again?
No. So I just thought if you are dealing, if you are going to apply the algorithm ML model here, then you can't use this text things, right? You have to make it in
Yes.
labeled format, some numbers, right? You will do 1-0-1, then 1-0-0, and here you can make it as day 1, day 2, day 3, day 4, day 5, day 6, day 7, something like that. So it depends on the objective of the problem.
So for
Okay.
emotions, how will we give? We cannot give already defined numbers, right?
No, so this data will be there, right?
No, for emotions, like if it is 111, it is happy.
Hmm.
So, so we are giving a label, right? So that can also be a, there can also be a number for that, no? When we give to an ML model.
So okay. Are you talking for number to this part?
Emotion one.
Okay. What do you think? Should I give or not?
I think we should give.
So you can give ordinal classification, like 5 for extremely happy and 0 for angry. So ordinal classification can work. Ranking.
Okay. See, it's
But sir, it will not work, sir, because it should be either 1 or 0. It will not.
That is if you have dummy variable ke liye you can use 0 or 1. But here anyways it is just output, so it does not necessarily need to have categorical variable attached. But if it were, maybe we could have ordinal ranking.
see basically here you have to give ordinal actually, because see you can say anger is I mean basically there is some order, right? Anger, then neutral, and then happy.
Happy.
Correct. You can't say this is nominal. First of all, you have to identify. I mean, in stats one, you have seen the what is the ordinal, nominal, and all. Correct. And then you can assign some numerical ranks, right? So let's say you can say 1, 2, and then 3 or something else, something like this, which is appropriate as per the problem. Okay, so but it will be you to assign in ordered rank. You have to assign the ordered rank actually. Okay, because there is some order. Correct.
Also, will it be useful for classification? This.
Okay, what do you think? So is this regression?
No, classification.
Yeah, it's a classification only, right?
It will be helpful. The emotion part will be helpful in classification.
Yeah, that's what we have to find out, right? We have to predict this emotion, right here.
Okay, yes.
Okay, so this is classification. There are 3 categories, right? Happy, neutral, and anger. Okay. So
Yes.
here we are not predicting any real number, right?
Yes, sir.
Understood? Yeah. Okay. What about this example? Which of the following are examples of unsupervised learning?
A, B.
A and B. Okay.
C is classification. D is also classification.
C is classification, which will come under the supervised.
Supervised.
D is also classification. Okay. Why C and D are classification? So C we know already whether spam. This mail is spam or not. Correct. Now, what about this? Identify the gender of online customers based on buying behavior. So this is again classification, right? You will let's say we are considering as of now, let's say 2 category, female and male, for example. Okay. Then there will be you are going to identify. You are going to predict whether based on their past buying behavior or purchase behavior, you will identify. You will categorize whether this is female or male. Now, if you see the first one, grouping twist based on topic similarity. So this is something unlabeled data set, right? And you are going to make see based on the topic similarity. So let's say first similarity, you can say okay, something good tweets or positive tweets, then negative tweets, and then neutral tweets, something like that you can group. And what about grouping songs into playlist based on similarity? Again, this is one of the example of unsupervised learning. Okay.
Sir, if you are grouping the songs, say for example, based on the singers, right? Like, will that be supervised or unsupervised?
See, that is something you are labeling. Okay, first of all, how you are giving your data set to the model. Okay, suppose you are giving a data set input plus output. Okay, so for example, you are saying one song, let's say song A, and this song is the name of the singer is, let's say A1, for example. Okay, and song B, then sing to B2. So basically, you are then classifying. Correct.
Yep.
Okay. Now it's based on similarity. You have listened some song, and based on your past data, this thing now what you are going to do, you are going to make a group of similarity. Let's say some positive vibe song or some slow song or some different kind of varieties.
Sir, can we say this what did you say, positive vibes or negative vibe as label? Like I'm having doubts in labeling. I couldn't
So
understand
labeling
what
is
is labeling.
what? See, this is something. Okay, for example, let me say here. Okay, so here, suppose I'm saying the house. Okay, this where it went. Let me go to. Suppose this data. Okay, this is one of the feature. Let's say x1, x2, x3. This is output. Correct.
Yes, sir.
Okay. Now this is labeled data set, right? This output is labeled. So labeling the data set means your final Y is labeled. Okay. You have target. Yes or no? So as we discussed, now this labeled data set will work as a supervisor whether this thing is correct or not. So what you will do, you will give this whole data set, let's say not complete data set, some 80% or some for training. So let's say you are giving these things, this much data set to your model. Okay, now that model will learn pattern, and then whenever you will give this new thing, it will predict this part. Okay, this is, you are dealing with labeled data set. Okay,
so which one is label? You mean to say shopping, housemaid, present, and walking are the labels?
see, no, these are the features.
Okay.
These
Sir,
are the
so the
features.
end result is the label.
Yeah, that's what you can
If they
say.
are specific, then we can say they are supervised.
Yeah, supervised, right? That's you.
Yes.
See, initially it has been supervised, right? Yes, yes, yes. Okay, supervised as happy. Okay. So basically, if you see the addition rule, if you see 133 or
So
some,
then what will be unsupervised in that case?
yeah, I will come to that, but don't worry. So what? Okay. So far this is clear. Labeled data set. So you can see the house price example also. So in house price example, you will be having number of rooms, area, distance. So this price, correct? Now this is labeled, right? You got for each features you have some target, right? Some output. Okay.
Yes, sir.
Now, what is the this unlabeled data? So I told you the examples of this text, image, or speech. Okay. Suppose for the speech itself, or let's say text itself, if you have, let's say, some millions of tweets, okay, and that's all, without any label, you have just a collection of million of tweets. Okay. Now what you will do, you will give this input, and then this model will identify, it will categorize the things basically. Okay, or it will group the things, okay, in different groups based on some similarity. That's what it's doing. You are not giving any output, or you are not labeling. So what is the meaning of labeling? Suppose there is an email, okay, and you have labeled this is a spam, and there is let's say email 2, you have labeled as a not spam, and then you are similarly you have data of, let's say, some thousand email which you have labeled, or you have your target. Basically this is output, just consider as a y, right? Whether this email is spam or not spam, correct?
Yes, sir.
Now what you will do, you will give this email and this, whether it's spam or not spam. So this label data, okay, and then this tool will decide, find an no, this will learn from the algorithm, and if you will give a new email, let's say there is new email, and it will then identify with this algorithm whether this is a spam or not spam. Okay, understood the difference? Here you have data plus label. In this case you have just collection of text or collection of tweets, that's all.
Okay, you're not specifying something for the
No.
ML model to do, then it becomes an unsupervised.
Yeah, that's what
model.
you see. Sometimes in real life, this is not practically feasible, right? How can you specify some 1 lakh or 12 lakh something, tweets?
So also the main
labels.
reason, one of the main reason for unsupervised learning is to find out characteristics that you may have not discovered.
Correct.
So
yeah,
which is why it is
unsupervised. And this is one of the reasons. See, suppose you are working as an analyst or in a company, and let's say that bigger company, and you have to report the kind of different kind of tweets to your manager, and suppose in 2 weeks you got some 2 lakh tweets. Okay, so are you going to explain each tweet separately to your manager? No, right? This is not a good idea, right? So what you will do, you will use unsupervised learning, because in that case it's not labeled, right? And then you will do this unsupervised learning, and let's say you may find some 10 group, or basically 10 clusters, 10 different clusters you can find, and then you can so okay, in the cluster 1 these kind of twists are there, in cluster 2 these kind of twists are there. Okay,
sir, excuse me, sir. In case of unsupervised learning, we are not expecting the model to predict something new.
No, yeah, It's basically it will group the things.
Okay.
Okay.
Group the past things only, huh? Not the new futuristic model.
No.
Future, it will predict future or not, sir? In the case of unsupervised learning.
Sorry, can you
Future,
come again?
some future prediction will do or not, sir? In case of unsupervised learning.
Okay, so what do you think then?
It should do.
Okay.
But there is no level, so then how can we say that it will predict?
No, okay. First of all, tell me what is this unsupervised learning?
The grouping of data present.
See,
I
grouping
think
is okay. Grouping is
in the
okay.
in the unsupervised, there's not no end goal in the unsupervised. It actually like group the data or compress the data so that we can understand something.
See, basically, the key idea about this, unsupervised learning, what is the main job of this algorithm is to find the, you can say, hidden pattern or a hidden group or structure in your data set. So that's why it's doing, grouping in different situations. Okay.
Hello, sir.
Yes.
Sir, in clustering, we have to define rules.
Sorry, interesting. See.
Sir, in clustering, we have to define rules.
No, so what is the point of that rule?
Like we have 1 lakh email to cluster in 10 groups. We should have some rules.
No. That's the job of algorithm actually. See what you have to do. You have to do actually in simple terms. You have suppose a data of let's say 1 million tweets. Okay.
Yes, sir.
Okay. What it will do, it will identify the hidden patterns or hidden group or some similarity, and then it will give you the different. That's all. So let's say some good tweets. So good tweets means there are collection of tweets which the meaning of the like let's say the kind of meaning, or you can say it's a good. And then there are some collection of tweets and what is the meaning of those tweets, they let's say they didn't like that particular product or something like that. And there are a group of people who tweets about, let's say they buy that particular product very frequently, and then something else, some group. So it will identify these kind of groups actually. Okay.
It will identify
Sir, it's a kind of
automatically.
pattern.
Sorry.
It will
So
identify
actually, it's a
automatically.
probability, right?
Yeah,
So
it's a probability. Correct.
How probable it is to fall under a good tweet?
Yeah, so
Okay.
basically we will there is yeah, that's what. So we will learn two things in unsupervised learning, that's called dimensionality reduction as well as density estimation. Okay, so these two
Okay,
things
sir.
are very helpful.
Sir, so this comes under density estimation, right? This 1 million tweet example.
Yes.
Sir, do we train the data in case of unsupervised learning?
Okay, can you tell me, is this okay?
No, we are grouping the data, but do we
That's all
train,
right.
do we
Sir,
train
we're
the
training
data, train the model in case of unsupervised learning?
The whole reason it is called unsupervised learning is because you don't supervise it.
There is no supervision, right? So I told you in the beginning, what is the meaning of supervision? And I told you what is the supervisor, who is supervisor, right?
Level, yes.
Here, do
Sir,
we have label data set?
Yes, sir. In case of in this case,
No, right? Here we don't have label data set, correct?
okay.
So could I use an example, sir?
Yeah, please go ahead. Yeah.
So assume you have 1,000 pictures of dogs and cats, and you feed it to an unsupervised model. The unsupervised model will just find certain features that it recognizes. So when you give the 1,000 pictures without any label, the unsupervised model will start finding features by itself. Say color of the fur, or whether it is a big animal or a small animal. Whereas in classification, you feed those 1,000 pictures of cats and dogs, and you say, okay, this is a cat, this is a dog, these are the features of cats versus these are features of dogs. then the
Yeah.
model will start recognizing whether this picture is of a dog or of a cat. So when
Correct. So
the
basically,
classification model will speak.
yeah, correct. Basically, you have to label whether that is dog or a cat or not, something like that. So suppose you have data of, let's say, some orange, and let's say then apple, and let's say some uh, banana, okay, something, and you have labeled everything, right? So some, let's say, some observation you have labeled as the orange, and then some observation with apple, and some observation with banana, right? These are the labeled, correct? Now if you will give any new fruit, I mean, among, let's say you took something else, and it will give you, and then it will predict, okay, this is whether this is apple or banana or orange, right? Are you getting my point?
Actually, in the output, we'll get how much percentage, how much probability it is for being. I mean, how it identified is as an apple. So if we give a figure like it is an apple, it will give a percentage like 98%.
Yeah, that's what this density estimation is coming. Okay.
Sir, like I have a doubt in the example which was discussed now. Say, for example, like unsupervised learning is for dogs and cats. Let me give the input as a picture of white dogs, white cats, black dogs, and black cats. Okay, like 4 different things. If I give it to unsupervised learning, it can either split as dogs and cats or black and white animals, but I don't know which, right?
Okay.
So what will be the output of unsupervised learning in this case? Like it can be any classification, right? It can be a classification of black animals, white animals, or it can be a classification of dogs and cats. But
that we need to feed it the algorithm.
Okay, so for unsupervised learning, will we pass as input the set of possible labels?
No labels. So
See,
you have a huge amount of data that you cannot make sense of. Unsupervised learning will make sense of the data. So the next time you have a fresh piece of information and you don't know what to do with it, this unsupervised model has learned from all of that data, right? So when you see the new piece of information, it tries to say, okay, based on what you've given me and based on all of the past data that I've been trained on, this is what I think it is.
See, what might be another?
Can you label a bit, sir? It are getting little confused. What is label basically, and who's labeling it?
No. So label is, see, that's what you are. Okay, first of all, okay, is this idea was clear or not?
So let us repeat. I believe a lot of confusion is there. We are not getting the label.
Okay, see, 1 second. First of all, what is the meaning of supervision? Means there is, for example, in suppose there is your teacher who is work as a supervision, I mean supervisor. If you are doing addition of 3 numbers, yes or no, and he will tell whether it's correct or not. Correct?
Yes.
Just okay. Now in machine learning, what is the role of supervisor? That the role of supervisor is the labeled data set. What is labeled data set? Okay, so let me take another again. This example is email one. So suppose what we will do. Suppose you have data of, let's say, email one, okay, which is you know, right, which is whether it is labeled as spam or not spam, okay.
But that's the result, right? Whether it is spam or not spam, that's the result.
First of all, that's the key thing about machine learning, right? You have to give the data, right? You have to first give the data. See, if you see this house price thing, you have to give the data of some number of rooms, area and distance, some price of house, then number of rooms, area, distance and price of house number.
That is the data.
Yeah, that's what I'm trying to say. So you might have some categorical data also. I'm
Okay.
trying to explain here meaning of labeled and unlabeled. Okay. Suppose you have email 2 with which you have labeled as not spam. Okay. Then email 3 spam. There is another email not spam. Now tell me, okay, if someone wants to explain now, what will be the next step?
Now, once this input are been given, the algorithm must understand what is it, and then any new mail coming should filter it spam or not spam.
Correct. Now there is a labeled data set is there. This is the labeled one. You have labeled the things, yes or no?
Okay, so you mean to say when we are giving, we are saying that it is spam, and hence all relevant.
And then it will find the algorithm, right? It will learn.
Okay.
Okay. So basically, this labeled is basically if your output is there. Okay. You have some example of output.
Okay, got it. Thank you.
Okay. So, but even see, suppose in medical diagnosis also, in medical area, suppose data will be what? Suppose there are some X-ray images. Okay. And what will be the labels? And you can say whether this is healthy or not. Okay. Let's say some another thing. Okay. And you talked about, let's say another case data will be, let's say animal photos. Okay. And what will be the label? Labels will be it's a dog or not, or sorry, dog or cat, let's say. So if you are giving these two things, your machine learning, then and what is the unlabeled data? You are just simply giving, let's say, million of pictures to the machine. Okay. Now you took the example of white dog and white cat, right? Yes or no?
Yes.
So let's try to understand what might be one of the possibility. I'm just trying to guess. So basically, suppose you have photos of white dogs and white cats. Okay.
White dogs and black dogs also. Like we can group them into two. Like dogs and cats are white and black. Like we can have 4 set of.
Yeah, that's what. Let's try to understand this one first.
Okay.
I mean, if colors are same, then what? Okay. So and suppose there are no labels, and we are not going to tell the algorithm. Basically, we are not going to tell algorithm, whether this is dog or this is cat. Okay. So basically, we are simply what we are doing. We are giving this data. Okay. Now, what input features could be? What will be the what input features could be? Let's say shape of ears and face structure and body shape and tail type and size and all. Okay. And see, here algorithm doesn't know whether it's a dog or cat. Okay. It only what it will do. It only sees the basically or identify the patterns in the features. Okay. So it will identify the patterns. Okay. So basically what it will do, the algorithm will group the similar looking animal together. Okay. So what are the possible groups? So there might be group 1. So the white animals. Okay. We don't know whether it's dog or not. Let's say white animals with, let's say, long ears or longer face. That might be, I can say this is likely dog. Yes or no? And then might be another group, white animals with short ears and rounded face, something like this. Okay. Likely you can see cats. Okay. So this based on the, I mean, algorithm itself. So what you have to do, you have to basically give the unlabeled data set. Okay. So in real life situation, sometimes it's not practically possible to label these things. Okay.
Sir, in case of unsupervised learning, it is only to the grouping or sorting the things only, na?
Yeah. It will identify the pattern basically. Okay. Okay. So let's try to do some questions. Okay. Is this fine? Okay. Is the doubt clear now? I forgot the name who asked this question.
Yes, sir.
Okay. Yeah. You got the idea, right? Now labeled and unlabeled.
Yep.
Okay. Yeah. Great. Thanks. So there is one question. Which of the following can form a good encoder and decoder pair for a d-dimensional data set? Which option should be correct?
Option 3.
Option
3. C.
Option C. Okay. Why?
Because the decoder must be smaller than the encoder.
Yeah. Basically, this is one of the example of situation of
Greater than
encoder and decoder.
Unsupervised learning.
I want to hear that word actually.
Dimensionality reduction.
Reduction. Yeah. Correct. It's one of the example of dimensionality reduction. Okay, great. Yeah. So this C option is the correct.
Sir, please explain. I didn't get that.
Okay, so have seen the lecture of dimensionality reduction.
Yes, sir.
So in dimensionality reduction, what happens? Suppose you have too many features. Okay, let's say you have some 50 features. Okay, understood? And you want to, and suppose dealing with this, it's sometimes very difficult, and you want to reduce the features or reduce the dimension in fewer, let's say 3 features or some 4 features, without losing too much information. Okay.
Sir, this is fine, but why the other options are not correct and C is correct is what I was trying to understand.
I will come to that point. Okay.
Okay,
so
sir.
What we are doing, we are reducing the dimension, right? So what we will do, there will be one encoder function. Yes or no?
Yes, sir.
Okay. And then you are decoding in something, in fewer number of dimensions. Okay. Now later,
Right.
what you will do to interpret the things, you want to come back to try to understand what was the difference with the original one, xi. Okay. So if you see in the C1, what is happening? So this D, we have what is the output basically? I mean, it's going from RD to RD dash. So this D dash should be less than D. Let's say 50 to 3.
Okay. Yeah.
Okay. In G, what decoder will do? Now you are going RD dash to RD, where D dash is again less than D. So D is the original one, which is 50, and D dash is the 3.
Okay.
That's why the option C is correct only, right? You can't say, if you see option number D, this is incorrect, right? So what you are saying, you are going RD to RD dash, and D dash is greater than D, means you are trying to say initially dimension was 50, let's say D 50, and D dash you are saying more than 50, let's say 60. That's not a good thing.
Okay, got it.
Got it? Yeah.
No, actually the interpretation was very confusing. So
okay. Now it's clear, right? The idea behind dimensionality reduction, right?
Absolutely clear, sir. Thank you.
So we have one question. Okay, I hope everyone is having pen and paper with you.
Yes, sir. We are.
Yeah. So what you have to do? So this kind of questions are actually important to solve. See, the theory fundamental idea is okay, but in exam we have to solve the questions, right? But anyway, let's try to solve this question. So questions is, consider the following data set where each data point consists of 3 features. Features are x1, x2 and x3, and these are the observations. That's the mean square list. Okay, I think there is something missing. Okay, there is something. Okay, so suppose there are 2 pair 1 and pair 2. Okay, so this pair 1, so this is encoder. Okay, and this is decoder. Okay, so you have to compute the reconstruction loss of each pair and identify which pair performs better. Okay, so you have some 4 to 5 minutes. Please solve it, and we will see which one is correct.
Who has lesser loss?
Which two of us has the lesser loss? So if you want, I can write the. So basically, what is the goal? This is one of the example of dimensionality reduction. Yes or no? So what is the goal? So this G of f of xi, this should be approximately close to xi. That is original data, right? So what is the loss? I'm going to write the loss, actually reconstruction loss. This is 1 upon n, summation of I is equal to 1 to n. Anyone, if you want to tell me, I can. It would be great.
G of f of x minus
G of f of xi minus xi. This is norm square. Okay. So you have to apply this formula for this pair 1 and pair 2, and then you have to tell me which pair has the which pair performs the better, which encoder and decoder performs.
Second pair performs better with a loss of 0.666.
Okay, too fast. How come?
Sir, we have done it already, na?
Yes, sir.
Yes, sir.
Uh, this example you are done. You have done.
Yes, sir.
Similar example present in a practice assignment.
Okay, that's what I wanted to test. So I mean the numbers are different, but similar examples. Is the answers also same? I don't
Numbers
think.
are different, sir.
Yes,
No,
the numbers are
different.
different. I'm sorry.
Okay, so you are telling the answers directly. That's why I'm thinking. Okay, can you calculate? Everyone, please.
Yes.
Yeah.
Yes, sure.
So where can we get the PDF to they solve with us questions?
This PDF, right?
Yeah,
Yeah. After this session, we'll upload on the portal under supplementary content.
but we haven't received the previous sessions.
Oh, is it? Okay,
Yeah.
we'll upload. Yeah, sorry about that. We'll upload these two PDFs after this. Yeah.
Sure, sir. Thank you.
I have one question.
Mm-hmm.
So, is there any like good book or any platform where we can practice more questions on every topic that is being taught?
Yeah, the same question someone asked in the last session. So I was about to put on the Discord. So we'll okay. I will check it out. Okay, and then upload on the discourse or inform you in the discourse or via
Okay.
mail itself. Okay,
So
I need to.
should I raise a question in discourse?
Yeah, you can. That's not problem.
Okay.
This line shouldn't be there.
Sir, I think pair 1 is better with low loss.
Okay, have calculated. What is the value?
I think it's 7.67. Maybe it's wrong because I've done it's too early.
Oh, just solve it, right? So because some approximately time you may get in your exam, right? Something. So we'll wait for 2 to 3 more minutes and then I will start with calculation.
Sir, is it pair 2 with loss of 2.9 something?
Even I don't know. I need to solve it. Just waiting to so that everyone can solve it. Then I have blank pages. We'll solve there. We'll cross verify. So you got for pair 2 2 point
2.9 something.
9 something. Okay. Is there anybody else who got some?
Yes, sir. 2.9375.
Okay. What about pair 1?
It is about 76.5. Not sure if I'm right, but
Loss 1, 76.5, and loss 2, 2.6875.
Okay. It's too much difference.
Yes, sir.
Okay. So should we solve, or should I wait? If any one of you is trying, then they can wait and then. Okay, shall we proceed? Yes, no? What do you think?
Yes, loss 1 will be around 76.5 and loss 2 is around 2 point something.
Okay, let's see. Yeah, okay. So can you tell me the observations? So x1 is 7, 12, 3, 10. So 7, 12, 3, 10. What is the x2?
5, 9, 2, 8.
5, 9, 2, 8. x3 6,
11, 4, 9.
4, 9. Okay. Now what we have to do? So what is the basically first f? So I'm writing f1. Okay, so f1 means pair 1. So 2x1 minus x2 minus x3. Okay, so 2x1 minus x2 minus x3. What will be the answer? Basically 2x1 3.
Yes, sir.
Yes, and then this will be
4.
4. Very good. And then
0.
0, yeah. And then 10, 20,
3.
Okay, great. Now what about f2? f2 is x1 plus x2 x2 plus x3 divided by 4. So basically f2 I'm just talking about f. If you want to write g, I can write. Okay, let's write g itself here. Decoder function. Let's say I'm writing g1 just for. So it will be
23 by 4.
333.
Oh, okay.
Yeah.
Yes.
Then 4,
4.
then 0, 0, 0, and then 3, 3, 3. What about f2? Second encoder function, it will be x1 plus 2 x2 divided by x1 plus 2 x2 plus x3 divided by 4. So it's I think
23 by 4.
23 by 4. So it's 5 point something.
Yes.
So direct 23 by 4 itself.
5.7.
5.75.
5.75. Okay. And then next pair will be 12 is 41 divided by 4, right?
Yes, sir. 10.25.
0.25.
10.25. And the third is
2.75.
Yes,
2.75.
11 by 4, 2.75.
Okay, great. And the third one is the last
8.75.
one is 8.75. Okay. So let's, what about G2 decoders? It will be 5.75, comma 5.75, comma 5.75. Then 10.25, 10.25, 10.25. So some of you might feel this is lengthy, but I think it would be easier. I mean, there is very less probability of making mistake if you are making table and doing this kind of things. Otherwise sometimes you may miss some numbers. Okay, so what is the loss actually? So if you see, so loss of, I'm writing pair 1, so it will be 1 upon 4, 1 upon n, so it's 1 upon 4, right?
Yes.
1 upon 4 summation of norm of, so g of f of xi minus xi square, right? So basically what you have to do, it will be if you see here, what I have to do, it will be
7 minus 3.
3, yeah, 3 minus 7, yeah, whatever. So basically I have to do norm basically 3 minus 7. So what it will be?
-4.
Okay, should I write directly this square part? Is that okay? Everyone knows this?
Yes, sir.
If I'm writing norm of x square, this means x1 square plus x2 square plus x3 square. Let's say we have, if x is vector of x1, x2, x3. So now here it will be vector of 3 minus 7, right? So basically what we have to do, 3 minus 7 vector of it will be then 3 minus 5 and then 3 minus 6. Okay, so basically what it will be,
16 plus 4 plus 9.
So
29.
basically it will be 7 minus 3 4 square plus 5 minus 3 2 square plus
So 29.
29. Yeah.
29.
So this is 29 plus then
138.
okay,
8 square plus 5 square plus 7 square.
yeah, and this is the easier, right? So again,
Again,
9 plus
4 plus 16, again 29.
29, yeah.
29.
And then this will be 7 square
110.
110. Okay, very good. So
Sir,
this,
please explain the steps, sir. I'm not getting it.
okay, okay, one second. I think I should write. Okay, so what is the thing here? If you see, we have to, this is norm square of g of g of f xi minus xi whole square, right? Correct. So this is the g of f xi, correct, minus xi. So xi contains these three elements, yes or no? And within g of xi we have three elements. So what we have to do, if you see the function g of f xi, g of f xi minus xi, norm is this square, right? So what it will be? It will be 3 minus 7, correct? These are the three elements of vector x, and this is the three elements of g. We have to do it will be basically, okay, let me write here. So 7 minus 3 is, or 3 minus 1 minus 4, and 3 minus 5 minus 2, and 3 minus 6 will be minus 3. So we have to find the norm square of this part. Understood? Plus norm square of the vector 4 minus 12, which is 8, 4 minus 9, which is minus 5, 4 minus 11, minus 7. Understood? So this is, you can say this is the vector. Yes or no? Are you getting?
Yes, sir.
Now
Yes,
then
sir.
it will be 1 by 4 outside, then plus norm of minus 3, minus 2, minus 4. Did you get from where I got this minus 3, minus 2, minus 4?
Minus 3 means 10.
0 minus 3, right?
Yes.
2 minus 2. 0 minus 4. Correct? Plus.
Okay.
It will be 3 minus 10, this, which is minus 7.
Minus 7.
Minus 5. Then 3 minus 9, minus 6. Understood?
Yes, sir.
Now we saw this norm square will be basically, if you will solve this, so it will be 1 by 4, and here it will be 4 square plus 2 square plus 3 square. Okay, plus minus 8 square, that is same as 8 square plus 5 square plus 7 square plus 3 square plus 2 square plus 4 square plus 7 square plus 5 square plus 6 square. Understood? Now what was the final value for this? I think 76 point something, right?
76.5.
76.5.
Yeah, so loss of pair 1 is 76.5. Now the same procedure you have to do for the second loss. So now what it will be? So initially you subtracted 3 minus 7. What you have to do? You have to subtract 5 minus 7, 5 minus 7. Understood? 5 minus 7, 5 minus 5. 5 minus 7, 5 minus 6. Okay.
Okay, sir.
Okay. The same procedure you have to repeat till the end. So should I calculate the loss of pair 2 also, or is it fine? You got the idea?
No, sir. I mean, at least one question, if you can solve, then it will be good. I mean, at least we'll have some reference to come back.
Okay, first part I solved. Okay, anyway, so what is the loss of pair 2? So it will be 1 by 4. So I'm not going to do this 1 by 4. So basically, okay, so what we have to do, okay, this summation I is equal to 1 to 4 norm of g f x I minus xi. This is norm square, right? Now, so we have to do for second pair. So this is this last column is for second pair, right? So if you see what you have to do, g of fxi minus xi. So we have to subtract 5 minus 7.5, understood, minus This 7 or 7 you can do in reverse. So 5 minus 7, 5 minus 7 will be what?
Minus 1.25.
1.25.
Different. So this is something we have to calculate. This is minus 1.25 comma. This 5.75 minus 5, 0.75. Yes or no? Are you getting the subtraction which we are doing?
Yes.
Now the third part is 5.75 minus 6 minus 0.25, right? This is the vector, and we have to do norm square plus some norm square. And what will be the vector inside there? It will be 10.25 minus 12, so it will be minus 1.75.
Yes, yes.
And then 10.25 minus 9,
0.75.
no, 1.25, right? 10.25 minus 9.
Yes, sir.
Right, then 10.25 minus 11 will give you minus 0.75. So this is one of the vector. Next is, let me write down, then norm square, and then the vector will be here. So you can see we are finding g of xi minus xi, the difference. So 2.75 minus 3, it will be minus 0.25. Now 2.75 minus 2, tell me, 0.75.
0.75.
Very good. Comma 2.75 minus 4, minus 1.25.
1.25 minus 1.
Minus 1.25. Okay. So this will be minus 1.25 vector, and then this is norm square. Then the last one. So it will be vector of 8.75 minus 10 will be minus 1.25. Correct? Then 8.75 minus 8 will be
0.75.
8.75 minus 9 will be
0.25.
0.25. Very good. Now, so now you know how to deal with this, right? So it will be 1 by 4, and this will be minus 1.25 square plus 0.75 square plus 0.25 square. Okay, don't worry. Basically, it's a minus 1.25 whole square. I'm just writing like this only. So anyways, square only, correct? Plus minus 1.75 whole square plus 1.25 whole square plus minus 0.75 whole square plus minus 0.25 whole square plus 0.75 whole square plus minus 1.25 whole square plus minus 1.25 whole square plus 0.75 whole square plus 0.25 whole square. So what was the answer? I think 2.93 something.
2.93.
Sign will be intact, right? Within norms, we don't need to change the sign, right?
No, it's a square, right? Actually,
just a square. Okay.
Yeah. So if I'm doing minus 2 square or 2 square, same thing, right? So that's why initially I didn't take this minus sign.
So that was the confusion. Initially we didn't take, but in the later part we started taking.
Okay. Let me write. Okay, let me write here. Awesome part. So basically it's a minus 4 square. I just wanted to, just for space I wrote like this.
Okay.
Is it clear?
Yeah.
Okay. This is something. The same thing we have to do minus 8 square and then minus 5 square and then minus 7 square and then same minus 3 square, minus 2 square and minus 4 square. So basically what is this norm square? If you have vector x equal to x1, x2, x3, so norm square is defined is like this. So whether it's a minus x1, again it will be x1 square itself.
Okay,
Okay,
because it will be square, the minus sign will go away, right?
go away. That's what. That's why I wrote like this.
Okay.
Okay, is the
Sir,
clear? Is
Yes, sir.
norm is always positive, so why are we still squaring the loss here? This the norm square in the
it's
loss.
norm is square. Okay. It's
Yeah,
not.
so
We are even yes.
norm is always non-zero, non-negative, na?
Yeah.
So why are we still squaring it, like for the comparison and all?
Okay, so basically that's if I'm writing x square, for example, right? So this is same as x transpose into x.
Yes,
Okay,
sir.
so this x transpose is x1, x2, x3, and this is x1, x2, x3. Now how will you do this multiplication? It's a x1 square plus x2 square plus x3 square. These things came from there. Okay.
Okay, so it's okay.
Okay, this is the basically in linear algebra part you will study the this is called inner product. Okay, inner product. Okay, so we'll do x. So this is same as x transpose x. Okay.
Yes,
Okay.
sir.
Okay.
So the next question is, suppose the ML team in a movie production company wanted to predict the whether a movie will earn 100 crore or not by using some classification model. Therefore, the team collected presence or absence of various factors, as x equal to x1, x2, x3 from the movies in the past, and the data is given to you in front of which you can see on my screen. So basically, you have to compute the loss if the model predicts using this g equal to z equal to 0.5 x1 minus 0.8 x2 plus 0.4 x3, and what is the condition u of z? It will be positive if z is greater or equal to 0 or 0 otherwise. So this is classification problem, yes or no? You can see clearly. If this statement is not mentioned, can you identify this is classification problem?
Yes, sir.
Okay,
Yes, sir.
if this is the classification, what is the loss here? If you want to calculate the loss, what is the loss?
Sign of
Sign of y, f of x not equal to y. F of z not equal to y.
loss is the sum of f of x, which is not is equal to y divided by n.
Sorry, loss is
So 1 by n into summation of
It is the proportion of the misclassified data.
yeah.
yes.
What I wanted to listen actually. So basically, loss will be 1 upon n summation of I is equal to 1 to
1
n.
to n. 1 into
It's
this
not 1 into, it's an indicator function actually.
India. Okay. Oh, yes.
So it's a fxi is
Not equal
not
to
equal to yi. So basically, what is this yi? So basically, you have data set, let's say x1 y1, okay, and x2 y2, right? So xn yn. So you can say, okay, first of all, this is labeled data set or not?
Yes, sir.
This is
It's
labeled, right? This is the data and this is the output, correct? And output is labeled there. Now, if you see, what is the possible outputs here? Here only two, 0 and 1.
Yes, sir.
Now, what you have to compute? You have to compute the loss, and this will give you the fraction of the training data, which is classified wrongly by this function. Okay. Now, what is the model? Is given as this part, right?
Yes.
Z basically f of x. Okay. Now here you see, if you see in the lecture, sir defined something like this. So f of x is defined as a sine of w transpose x plus b. Correct. Now here instead of f of x, it's written as z. And what is this? So in within we are interested sine of this part, right? So you can see this is w1, w2, w3, something like this, right? And here what is the condition? If z is greater or equal to 0, you will take 1, otherwise 0. Okay, so now you can attempt the question. I am
Sir, what does this label 0 and 1 are representing here? 0 means greater than 1 crore revenue, or what? True or false?
accept true, right? Sorry, 0 is false.
Here 0 is false and 1 is true.
So you have to okay, just find the loss and tell me.
So total loss is 0. All the predictions are correct, like same.
No, it is coming out to be 20%.
Whatever.
Yes,
Yeah,
yeah,
just
just
calculate
20%.
it. Okay. I'm giving 5 minutes to all of you. Just try, and please try. I would request to all of you to try, at least, so that you can get some sort of idea how to solve these kind of things mathematically, at least.
Fit tissue.
Sir, is it 1 by 5?
Yes, sir. It is 20%.
Yeah, 0.2 into, yeah.
Yes, sir, it's 20%. I miscalculated.
Sir, is this PPT is available in the dashboard afterward the session?
Sir, you're muted.
Oh, sorry. Sorry, I forgot to unmute. So till now, is it okay? So we wrote the x.
Sir, I didn't get how 20%. I got the value of z. After that, I don't.
Yeah. I will come to that point. Don't worry. We will discuss.
Okay,
So I'm
okay.
solving. So how this z is defined as 0.5 of x1 minus 0.8 times x2 plus 0.4 of x3. So this is x1, right? This is x2, and this is x3. So
Yes, sir.
0.5 times of x1, it will be 0.50 minus 0.8 times 1 plus 0.4. So basically minus 0.4.
Yes, minus 0.48.
And what about this 0.5 plus
0.9.
0.9? Very good.
0.9.
And then
0.5.
0.5.
0.5, and it will be 0.5 minus 0.3.
Yeah, next one is 0.1.
0.1.
Yeah.
Negative
Last
0.3.
one is negative 0.3. Fifth one.
Minus 0.3. So what is u? If you see u defines the sign of this part,
Yes,
right? Sign of z, right?
if it is positive, then sorry, if it is greater than 0 or 0, it is 1, or otherwise 0.
Correct. So now
So
if you
in
see,
first and last case, we are getting 0.
okay, so this is 0,
Yes.
and this is
1,
1,
1,
1 and
1.
0.
0.
Now, if you see the loss function, right? If you see the loss function, how loss function is defined? Loss function is defined as it's a basically fraction of misclassified part, right?
Yes.
It's an indicator of where f of xi is not equal to
f of a.
yi.
Yes.
Yi, right?
Yes.
So if you see, how many observation is not equal to the yi?
One. Only last option is not correct.
Only last, right? This, if you see, if you see, this is equal to this. This is correct. This is correctly classified, right? Correctly classified. But the last is wrongly classified. So this will be 1/5, which is 0.2.
Oh,
that's all.
Okay. 1/5. Got it.
Okay. So n is what? What is the total? Total is 5. Correct?
5.
Understood?
So if we got 2 or 3 misclassified data, then it
will be 2/5. So basically, this indicator function you have to check for how many cases this f of xi is not equal to yi.
Okay, sir.
Okay, yeah.
Thank you.
Yeah, this page is remaining. Okay, so the last, I think this should be last question. Yeah, so the final question is, you have been given a data set xi, yi, and the regression model is given to us. It's very simple, which is x plus 2. You have to compute the mean squared loss of f of x on this particular data set. Okay, so I think I'm giving you some 3 to 4 minutes, solve it and let me know the answer for this data set.
Sir, is the mean 2.8?
Yeah, I'm also getting the same.
Sir, I
Okay,
think it's the
so
answer. Mean squared
2.8
loss.
is everyone is getting 2.8?
Yes, sir. Yes, sir.
Okay, let's try to see. So first of all, what is the loss in case of regression problem? So loss is defined as a, yeah, tell me, 1 by n.
1 by n into f of xi minus yi.
F of xi minus yi.
Whole square.
Basically, this is mean squared loss, right? So if you see, first of all, what we have to compute? We have to compute the f of xi, right? So what is the f of xi? So let me write 1, 1, 2, 2, 3, 4, 4, 5, 5, 5. So 1, 1, 2, 2, 3, 4, 4, 5, and 5, comma 5. These are the xi comma yi, correct? Now, what is the f of x? F of x is x plus 2. So let's make the table. So let's say what is the x? So x is 1, 2, 3, 4, and 5. Oh, I think. And what is the f of x? Or sorry, what is the yi here? 1, 2, 4, 5, and 5. What is the f of x? So x plus 2, that is 3, 2 plus 2, 4, 3 plus 2, 5, 4 plus 2, 6, 5 plus 2, 7. Correct? Now, what is the next thing? We have to find the difference between this f of xi minus yi and then whole square. So f of xi minus yi whole square. So 3 minus 1 whole square, that is
4.
4. Let me write if someone is it later. So basically 3 minus 1 whole square, that is 4. 4 minus 2 whole square, that is again 4. 5 minus 4 or whole square, that is 1. 6 minus 5 whole square, that is 1. 7 minus 5 whole square, that is 1. So what we have to do? So loss will be
Last one is 4, sir.
oh sorry, yeah, 4. It will be 5, 1 upon 5, and we addition of these 4 things. So 4 plus 4 plus 1 plus 1 plus 4. So
14, I think.
14 divided by 5, which is 2.8. Yeah, so this is the answer. So those who have done is correctly, it's the correct answer. Okay, so you got the idea, right? How to solve this kind of loss functions and all.
Yes, sir.
These things, right? I think week 1 is easy, also no. You find too much.
Yes, sir. Yes, sir. Yes, sir. Where can we find this PDF, sir?
Yeah, I will upload after this session on the portal. You can find it under the, basically you can go to the supplementary content. We will upload here live session notes. Okay.
Okay. Okay.
Yeah.
Thank you, sir.
After this session, I will upload that. That's not a problem. Okay. So I think yeah. So thank you and keep learning. So you got the idea, right? Anything else? Or any doubt in AQPA, or is it fine to all?
Sir,
you are done with everything. Yes, yeah.
I learned this word that some in other PPT and all this thing. Semi-supervised learn. Like what is that?
Okay. Don't worry. Don't go with that semi-supervised learning.
Okay.
As of our foundation, we just start with supervised and unsupervised learning.
Okay.
Even in regression and all, there are multiple things. So see, for week 1, what we are creating, we are giving just a, you can say a flavor of these machine learning things, right? So what is the regression, what is the classification? Even if you learn later, so within the classification there are lots of things. In regression there you'll find lots of things. In dimensionality reduction you will learn about principal component analysis, and also those things will come later also. Okay, so don't worry about those things, it will be discussed. Okay.
Thank you, sir.
Yeah.
Sir, regarding the supplementary content uploading, can you tell the same to the TAs?
Okay, all right. Yeah, so both are
okay.
Well informed. Yeah.
Okay, thank you, sir.
Okay.
Sir,
Yes.
you'll be uploading the previous PDF that you used as well, right?
In open session, right? I will upload both. I don't know whether it is you will be.
No, sir, you cannot access the PDF in calendar
No.
currently.
Yeah, so I will upload. What I'm saying,
Okay.
I don't know whether it will be understand. I mean, you can understand later.
Sir, we'll be able to understand. I think your handwriting is clear enough.
Okay,
Will be helpful, sir. Yeah.
Okay. Then that's fine. Yeah.
Just want to add on to my notes. That's all.
Okay. All right. No problem. I will upload.
Thank you, sir. Thanks a lot.
Yeah. Okay. Thank you. Thank you all. Bye.
Thank you, sir.
Bye, sir.
Thank you, sir.
Thank you, sir.
Sir, I have a question.
Hmm.
I'm following you from the statistics 2 course. Your teaching is good, sir, and it's able to understand well when comparing to other. Do you continue for this is ML foundation? Do you come further like ML practice and other ML steps maybe?
Okay, so I'm not sure about this term because see, right now, so I'm teaching this MLF. So later I can, but I can't come. There are other instructors also. So
yeah,
those who are
current time I
teaching
only
this,
took MLF only. Next time, if
yeah.
possible, try to take some.
Okay, sir, I will try. So because I am engaged in some degree level courses also, so I'm not
Okay,
sure.
sir. Okay, sir.
But yeah, I can't comment 100%. But yeah, we'll see.
Okay, sir. Try as much as possible.
Okay, sir.
So, by the way, your name, sir?
Okay, so my name is Prasant, sir.
Oh, good to know, sir. Thank you.
Yeah, thank you. Bye. Thanks, all.
Yeah, sir. Even I am following from stats 2 only.
Okay. Great. Yeah,
Thank you, sir.
Good to hear. Yeah, thank you.